Now, take a look at this. It's an equation that featured on a GCSE maths paper, and needless to say, it left many students confused and dumbfounded, with some even taking to social media to complain to the exam board about this conundrum. This was the question. There are N sweets in a bag. 6 of the sweets are orange. The rest of the sweets are yellow. Hannah takes a sweet from the bag. She eats the sweet. Hannah then takes another sweet from the bag and she eats that sweet. The probability that Hannah eats 2 orange sweets is a third. Show that in n squared minus n minus 90 equals 0. Well, for those of you who are still struggling to work it out, we're now joined by a man who can help us, so-called mathematician Andrew Jeffrey. Now, just how difficult is this problem?
Good morning, Gillian. It's a really hard question to answer that. How difficult is it? Well, yeah, it's interesting because students see something as easy as what they can do, and so it's easy for one but not for another. I think the main difficulty from this question didn't come from the mathematics in it. It came from the context and the fact that there were 2 completely disparate aspects of maths joined together, and that's what threw the students.
So the fact that it was layered and there were several areas that they had to go through before arriving at the answer, that's the main problem, you think?
I think it is, and I think it's not obvious because one of the ways that students are taught is they're taught very much kind of mathematics, often in silos. We're taught like, OK, let's do a week on probability, let's do a week on this, let's do some algebraic manipulation, let's do some equation solving. And actually, they're not really taught, or some of them are, to put those things together and to see maths as a big picture. It's the example I often use is, for example, a triathlon. And if you were said to someone, look, I'm going to do a triathlon, well, is that really hard? I know nothing I've done before, but actually it's swimming, it's cycling and it's running. And if you put those things together, then you get something worthwhile. I was looking around your studio this morning waiting to come and talk to you, and I see so many people doing so many different jobs, and all of those jobs have a greater purpose. And I think if we can show everyone that mathematics is not about learning individual skills like learning how to use a hammer, learning how to use a chisel, learning how to use a screwdriver, but it's about what you can build with those tools, and then I think that'll be more appealing.
So it's a broader picture.
Absolutely.
Now, you're here for a reason. You're going to take us through the problem and explain it step by step so even I can understand.
OK.
Let's have a go.
All right, don't do yourself down. Can we have a look at the question? Can we have a look at the question
coming up for us with Hannah.
I'll tell you what, while we're waiting, do you want a sweet, Gillian? I've only got yellow ones. There's no orange ones left.
Oh dear, I always go for the red ones, but I'll take the yellow one especially, even though my name isn't Hannah. We had lots of tweets actually last night talking about this question. There it is. There are N sweets in a bag. 6 of the sweets are orange. The rest of the sweets are yellow. That's the start of the question.
Here we go. So, in terms of probability, to choose 6, there are 6 sweets that are orange out of possible n. The chance, therefore, that you choose an orange one is 6 out of n. We can write that as a fraction, 6 over n.
6 over n, right?
6 over n.
With you so far.
Once that sweet is eaten, then 2 things now change, if it is orange. The first thing that changes is there are only 5 orange ones left, and the second thing that changes is there is 1 less sweet in the bag altogether, which is therefore n minus 1. So the second probability is 5 over n minus 1. All right? Now, in probability, children are taught to multiply those 2 things together to find the probability that both those things happen. So you take 6 over n as a fraction times 5 over n minus 1. And we're told that the probability that happens is, in fact, a third. Now, therefore, that gives us an equation, not a particularly nice equation, but certainly well within the reaches of a lot of GCSE students. And so you have the multiplied probabilities, 30, 6 5s, over n times n minus 1 equals 1/3. Rearranging that equation will give you that equation, and that's what they were asking for. Are you still alive?
I was with you up until a point, but I have to say, maths is not my strong point. But many people looking at this will think you're either very good at maths or you're not. You have that brain or you don't. Do you subscribe to that theory?
I absolutely don't subscribe to that theory, and nor does the vast, overwhelming body of evidence and research. It's all to do with our mindsets. It's all to do with how we see maths. If we see maths as a series of rules to be remembered and rather pointless, and actually, to be fair, it seems rather pointless working out probabilities of sweets in bags, but it's just an interestingly chosen context, perhaps not a wise one given the situation. But Maths is not that. Maths is about spotting patterns, and human beings are very good at spotting patterns. When you spot patterns, you can predict. When you predict, you can stay alive as a species. So seeing the big picture of maths is really important. For example, those tools I mentioned earlier, if all you ever did in, say, a woodwork class was cut bits of wood and then saw other bits of wood and screw other things and measure other things, but you never actually made a bench, you could be forgiven for not realising there was any point to it. And it's the same with mathematics. I think we've got some fantastic teachers in this country, but they're under a huge amount of pressure to teach topic. And if we step back and look at the combining and the why those things go together, I think children would enjoy and understand maths a lot more.
Andrew, Jeffrey, thank you so much. But if I'd been in that GCSE exam, I think I would have complained also. But thank you very much.
Okay.
I understood to a point. Thanks very much for coming in.
Okay, thank you.